Hello and welcome to Scope Talk. Today I'm going to talk about the DC Factory by Carl Martin, and I will compare and explain linear transformer-based power supplies and switch mode power supplies. Let's have a quick overview of the specs of the DC Factory. It's a switch mode power supply with 10 DC outlets in total. It features 8 9-volt DC outlets and 2 12-volt outlets and offers 2500 milliamps in total, which is enough also for high current drawing digital devices. It has a modular design with 5 separate power supplies in one unit, which are 100% isolated from each other. Each power supply has 2 outlets. Let's go into the technical stuff and start with the classic linear transformer-based power supply design and how it basically works. Let's have a look at the transformer in general. A transformer consists of a core made of ferromagnetic material, like iron for example. It has a primary coil on the input side and a secondary coil on the output side. The number of windings defines the ratio between incoming and outcoming voltage. If you have a ratio of 10:1 for example, 100 volts on the input will be transformed to 10 volts on the output. This is called a step-down transformer. Important note, a transformer only works with alternating current, not with direct current. The basic design of a power supply starts with the 230 volts AC we get from a wall socket, at least in Europe. This goes into a transformer, and on the output side we get 9 volt AC. Since most of our pedals work with DC, we need to add a rectifier to get a direct current. What a rectifier does is to flip the negative voltage to the positive side. As part of the rectifier circuit, there's also a condenser that smoothens the input in order to get DC voltage. Of course, we want to have more outputs than one, and the easiest way to achieve this is to daisy chain the outputs. The flaw of this non-isolated design is that all outputs share the same current, which might cause problems for pedals to work and result in noise. Furthermore, voltage doubling via a special cable for pedals that run on 18 volts is not possible. There's a better design though with isolated outputs. You can achieve that by using a transformer with several secondary coils followed by the rectifiers. The isolated design allows voltage doubling and is less noisy than the daisy chain version. There are still some issues though that apply to both the isolated and non-isolated supplies. The output of this linear design always depends on the input. Oftentimes you don't have 230 volts exactly at the input, it might be a little bit higher or lower, and the output varies accordingly. The transformer needs to be relatively big and heavy, and it might induce noise and hum to some pedals that are close by. Wahs are prone to this, for example. In addition to that, you'll get a higher ripple when the pedals need a lot of power. Let me quickly explain what that means. Ideally, we'd like to have 9 volts DC, that are always 9 volts exactly. In real life, you always get a little ripple from a power supply, which means the power continuously varies a bit around the 9 volts. When you have a big load connected to the output of your power supply, the ripple can get quite high, which might cause problems for your devices to work properly. Now let's have a look at the basic design of a switch mode power supply. This is a little bit more complex, but please bear with me. We start again with the 230 volts AC from our wall socket, but now we hit a rectifier right away and we get 230 volts DC. This is followed by a switch. Of course, it's not a literal switch, but a transistor. You can think of this switch as a tap that gets opened and closed very quickly and pours out a little drop of water every time we open it. The drops represent the power that is made available. By opening and closing the switch or the tap regularly, we get little drops of power in a steady pulse. The faster we do this, the more power we get within a certain time frame. So a higher frequency of switching means more energy is being transferred. The amount of switching operations of a switch mode power supply starts from 10,000 times per second and can go up to 100,000 times per second. So that's the switching frequency from 10 kHz into megahertz territory. What I also need to point out is that a pulse can be interpreted as some kind of alternating current. This is important for the next step in our power supply, which is in fact again a step-down transformer. What many people don't know is that the size of a transformer is not only dependent on the power it needs to handle, much more so the size depends on the frequencies it's supposed to deal with. Keep in mind that the transformer for the linear-based design works with 50 cycles per second, and this one deals with at least 10,000 cycles. Let's go on with the parts we need in our switch mode power supply. Of course, we also need a rectifier to get direct current. And here comes the ingenious part, a meter. The meter constantly measures the output voltage and is connected to the switch. When the meter is set to 9 volts, for example, it will tell the switch to work faster when the voltage is too low or work slower when the voltage is too high. What's also important in this design is a noise filter that filters out the noise the switch might add to the circuit. Now let's compare the linear transformer-based power supply design to the switch mode power supply. The one is relatively big and heavy, and the switch mode power supplies can be very small and light. Transformer-based ones are not very efficient and can get very hot. The switch mode power supply is much more efficient and usually doesn't get too hot. The output stability may vary due to the input source and the load. On the switch mode we have a regulated output that keeps the voltage stable. On the one side we have a higher ripple when more power is needed. On the switch mode ones the ripple is negligible. The big transformers can induce noise to other devices. This doesn't happen on the switch mode power supplies, but you need a good noise filter for the switching noises. As a bonus for the switch mode power supplies, those can be used from 100 volts to 230 volts. So let's get back to the DC factory. Because of the smaller design, it is possible to put 5 completely separated power supplies in one box. Those are 100% isolated and regulated units, which ensures clean power for your pedals. This wraps up today's episode of Scope Talk. Thanks for watching, see you next time.